Ladies and gentlemen, eyes up. All bets are off now. This is Count It In. How many ways can 6 different video game cartridges be arranged on a shelf? This is an example of a situation where arrangements will matter because we have here 6 different cartridges and they are all to be placed on a shelf. This could be answered in 2 different methods. For this time, we are going to use the fundamental counting principle and we will be having the same problem as we look into the idea of permutation, because permutation talks about arrangement of objects without repetition. So here we are assuming that all 6 cartridges can be arranged on a shelf. That would mean that there are 6 placements: 1, 2, 3, 4, 5, and 6 placements for our shelf. Now, the fundamental counting principle allows us to place in each placement the number of possibilities that can be placed there. In short, the number of cartridges that we could place in each placement and multiply them as numbers. That would mean for the first placement on a shelf, we can place here all the 6 cartridges. Okay? Say for example, we have a cartridge is colored yellow, green, blue, orange, red, and let's say purple. All of those 6 cartridges can be placed in the first placement. Now, since we are arranging the 6 cartridges on the shelf and all of them can be placed there, and if we are going to pick already one cartridge here, that can no longer be placed on the second because that's we only have unique 6 cartridges here. We cannot place the cartridge or one cartridge in 2 different placements. In short, in our second placement, the remaining possible cartridges that can be placed here would be 5 because 1 was already removed or 1 was already placed on the first placement on the shelf. With this in mind, the third placement can only occupy 4 of the remaining, because if 1 is used here, the third cartridge is used here, we are left with 4 different cartridges that can be placed on the third placement. Next, we are going to place on the fourth placement only 3 different cartridges left. Okay, because we have used already the first 3 on the first 3 placements. To be followed on the 5th placement, we only have 2 possibilities, and right after we have placed all of the first 5, since we only have 6 cartridges, we are now sure that there's only 1 cartridge that will remain for the last placement. Okay, so for example, you use here the yellow cartridge, then here would be the blue cartridge, here's the purple cartridge, the green, and the orange. Okay, you're now left with the red, and that's the only one remaining for the last placement. The fundamental counting principle allows us to multiply all these possibilities. That would mean 6 times 5 times 4 times 3 times 2 and times 1. The result of this would be the number of possibilities or ways for us to arrange the 6 cartridges on the given shelf, wherein all of the cartridges are included. That would mean again 6 times 5 times 4 times 3 times 2 and times 1. There are 720 possibilities or possible ways for us to arrange the 6 different video cartridges on the given shelf. This is the answer. Before we end this situation, let's understand this important notation that we can use especially for this type of situations that involves no repetition of objects in specific placements. This product of 6, 5, 4, 3, 2, 1 can be rewritten in this manner. You have 6 factorial. This means that we are multiplying n, which is our 6, by n minus 1 until 1 here. So this is again n minus 1. Our n here is 6, okay? Because we have 6 placements in the shelf and we have 6 video game cartridges. So you have, that's n here times your 5 is n minus 1, your 4 is n minus 2, so on and so forth until you reach a product or times 1. This notation will be used, as mentioned, for situations where there are no repetitions and with specific placements, in that this is actually the same as 720. In the succeeding videos pertaining to this kind of situation, and as we touch later the concept of permutations, we'll be using this notation, the factorial notation. And this is Counting In, talking about getting the luck of the draw. For all in, subscribe now.